Okay, here's a quick video on Sine Law and the ambiguous case. So ambiguous case just means that there's a problem that has more than one solution. So we have a problem. So we use the Sine Law when we know certain sides and angles in non-right angle triangles. So here, we're given a triangle that I haven't fully drawn yet, where one side's 10 kilometers, one angle is 48 degrees, and they're telling us another side measurement is 8 kilometers. So the problem is, the side that they're telling us is 8 kilometers is this side opposite 48. So the problem is, we don't know what the triangle looks like because we're not given enough angles to know. So this could be 8, this dotted line. Sorry, I can't seem to draw an 8. So that side could be 8, or 8 could also be out this way. So those both have a side length of 8. So we're just not really sure, like, would our triangle be this big outside one with a with an acute angle here? Or would our triangle be this small inner one with this obtuse angle here? So we're not really sure because given this information where you have two sides, a 10 kilometer side and an 8 kilometer side, we're just not really sure which triangle we're given. So just to say that again, when you're given two sides and an angle that's not in between them, there's an ambiguous case. So here we have an angle of 48. We're trying to decide, does our triangle look like this? Okay, sorry, that was bad. Does our triangle look like this, 10 and 8? Or does our triangle look like this with 48, 10, and 8? So we're just not really sure what our triangle looks like because we were only given one angle and two sides. So anytime you're just given one angle, okay, my pen's not really working great, one angle and two sides, and the angle's not in between the two sides, so it's not here, we need to consider the ambiguous case. So we have to consider, hey, we could have two different triangles here. We don't know which one it is. So we don't know if this angle here is going to be really small or really big. Okay, so how do we figure it out? Well, we gotta consider both options, and then we'll see what happens. So let's figure out what our two angles could be. So we'll try to figure out our yellow angle here first. So using this triangle, we've got a side that's 10, a side that's 8, and an angle that's 48 degrees. So we're going to use the sine law, so we'll set that up. So we have 8 over sine 48 because they're across from each other equals, and then we'll pick the other two that are across from each other. So let's call this angle B. So 10 is across from angle B, and we don't know what that angle is, so we'll call it sine B. So then we'll solve for sine B. So we will, I don't know, however you want to solve for it. So you could cross multiply here or multiply both sides by sine B. So if you cross multiply, you get 8 sine B equals 10 times sine 48. And we want to get rid of that 8 so we can get sine B alone. So I'm dividing both sides by 8. And I figure out that sine B is equal to 10 sine 48 divided by 8, which works out to about 0.9289. And then if I take the inverse of sine -1 of that number, it gives me 68 degrees. Okay, so now I know this angle here is 68 degrees. Okay, so for continuing on with this triangle, so now we've just found out that this angle here is 68 degrees in our big triangle. So if we ultimately want to find the length of this side, if that's our goal, we could find this angle here. So that angle is just going to be 180 minus 48 minus 68, which equals 64 degrees. So that angle is 64 degrees. So we're just assuming this big triangle is what we're working with here. Now we found that 64, so now we can find the length of the bottom if we want to, which we might as well. So we'll just use our sine law again. So we're trying to find the length of side x over sine 64 since it's opposite side x. And then we can use whichever other sides. We can do 10 over sine 68 or 8 over sine 48. Doesn't really matter which one you do. So I'm going to do 8 over sine 48. Okay, and then I want to isolate x. So I'm actually just going to multiply both sides by sine 64. So 8 divided by sine 48. And then I'm going to multiply that side by sine 64. So that guy cancels out. And the answer to that would be about 9.7 kilometers. 9.7. So we've just figured out this whole triangle, an angle 48, 64, and 68 degrees. And those are our three sides, 10, 9.7, and 8. And if you didn't know anything about the ambiguous case, that is the answer you would get. That's the only answer you would get if you're in grade 10 math right now. But now that we know something about sine and the way it repeats itself when we graph it, and remember when we did the, we stick things on a graph and we use our special triangles to figure out, something of this angle is actually the same as this angle, but some are negative, some are positive. So all that stuff we've just been doing in expectation D1. Well, we can actually use that knowledge to solve for the ambiguous case. So see this smaller triangle right here? Well, we know now that, hey, that could be the triangle that this question is talking about. So we have a side length of 10, an angle of 48, and a side length of 8. So let's assume maybe it's the small triangle. So let's try to figure out what that angle would be in the small triangle. So using the sine law, like we already did, 8 over sine 48 equals 10 over sine b, we still come up with an angle of 68 degrees. But we now know that we could figure out this obtuse angle by just going 180 minus 68 degrees, which equals 112 degrees. So now we know this angle here could actually be 112 degrees because sine b of 0.9289 actually has multiple degree answers. So b could be 68, 112, and a bunch of other answers too. So angle b could be a whole variety of things. But in a triangle's case, it can only be these two, 68 or 112, because we know angles in a triangle are going to max out at 180 degrees for all three of them. So for a triangle, we just have these two options. So we got 112 and 68. So let's try to solve for this little triangle. I'm just going to use an extra paper. Okay, so now we're dealing with this triangle. So now we're dealing with this triangle. So we just found out this is 112. This is 48. This is 10 kilometers. This is 8. And if we wanted to find this angle here, we would just do 180 minus 112 minus 48, which is 20 degrees. And we could just do the same steps. So we just do the sine law to find out the missing side. So x over sine 20 equals, pick any angle. So say we did the 8 again. 8 over sine 48. And then I want to isolate x. So I'm just going to multiply both sides by sine 20. Multiply this side by sine 20. Multiply this side by sine 20, so it cancels out. So x is equal to 8 times sine 20 divided by sine 48, which is equal to 3.7 kilometers. From that example, we actually have two totally valid options for this question. So given this information, 48 degrees, 10 kilometers, and 8 kilometers, it's actually not enough information to figure out one answer to the question. So it turns out, given the exact same information, you could have two totally different triangles. Well, not totally different, but pretty different. So you could have a triangle that's got an obtuse angle of 112, an angle of 20, and a side length of 3.7. Or you could have one that has an angle of 68 degrees, 64 degrees, and 9.7 kilometers. So both of these are correct answers because we don't know enough information. Like if you're only given two sides, like 10, 8, and an angle that's not in between them, you'll have two possible options most of the time. So pretty much sine law in the ambiguous case means you're not given enough information to determine which triangle is a valid triangle. So anytime you're given two sides of a triangle, one angle that is not in between the sides, you have to consider the ambiguous case. So you have to consider there's two right answers here. It's not enough to just say, oh yeah, it's this triangle. Nope, now we have to figure out, ooh, actually it could be an angle of 112 here.